So for the next 2 hours or so, we're going to go over the design of post-tension podium slabs. A lot of this will be photographs in terms of construction-related topics, not so much the numerics or the design. A post-tension podium slab is effectively just a two-way slab, which I give another webinar on for the more intricacies of two-way slab design. This will focus more on the uniqueness of a podium slab and all the different aspects that go into it, which usually make it the more complicated process, not so much the numerics. A slab is 12 inches thick or it's 8 inches thick. The design concepts really don't change, but what makes a podium slab interesting is all the interaction effects of all the different trades that go into it, and that is something that we will focus a lot on. If you do have questions during the seminar, or excuse me, the webinar, obviously please type them up in each of the breaks. I will try to respond the best I can. I provided my email address on the bottom of this slide, which you can see, and then obviously in the last slide. If something does come up, please feel free to email me. I usually get back to you within the first, if I see the email, I usually get back to you within the first hour. I see it. If not, I saw something shiny and forgot, but at some point I will get back to you. I'm more than happy to answer questions after the seminar if you do have them. So moving forward, the vast majority of the stuff I'm going to cover is covered in more detail in our book, Post-Tensioned Concrete Principles and Practice. We have a 4th edition out. Obviously, the 4th edition is obviously came after the 3rd. We added about 35 or 39 pages of more information. A lot of it has to do with podium slabs, stud rails, stuff like that. So if you are interested, I think there's a PDF, soft copy, e-copy, and a hard copy if you're so inclined to look into that. Now, podium slabs in particular, the classical definition is basically a slab that supports a separate building. In the West Coast, I think even throughout most of the U.S. and Hawaii, basically you have a concrete structure that has parking and retail below it, and then supports a wood frame or metal stud structure on top of it. So a lot of times that is parking and retail that is separated into units, typically apartments or condominiums where people live and obviously park underneath. Typically they use a two-way slab as a primary floor system. You can use a beam system to do it. Long span beams are typically more seen in garages. Nothing wrong with that, of course, but the beams, because of their depth, will often create path of travel issues or some complexities with the plumbing lines, electrical lines, and stuff like that. So not that it can't be done, I just think because of just the amount of stuff that has to travel below and through the structure, a lot of times more beams will cause some more problems. The slab as itself is obviously designed the vertical dead load in combination with the horizontal, the shear and the overturning forces of those structures. Typically, for the most part, that is plywood shear walls or metal stud shear walls. Occasionally have some moment frames for courtyard areas, gym, leasing office, stuff like that, where they don't want walls coming straight down on the structure. And those have their own unique aspects that we will get into a little later on. The engineer of record for the podium structure, being the concrete box, and the wood structure do not have to be the same individual. Obviously, that is my case. We specialize in concrete. I couldn't design wood if my life depended on it. So in those situations, a lot of times you have two completely different structures, two completely separate drawings, and obviously two different engineers of records, and we've never once had an issue with that in dealing with the cities in terms of, you know, the classical, who is the engineer responsible. Obviously, there's lots of engineers working on any one particular project. So podium slabs, due to the rigid stiffness of the concrete box, being the concrete podium structure, and you have a very flexible, relatively, of course, flexible building on top. The buildings are considered separate, so there is no vertical combination of lateral forces. Just from a purely conceptual standpoint, if you have a concrete building, the wood structure on top cannot take the vertical load distribution if it was considered one structure. So obviously they are considered two separate buildings, and two separate lateral analyses are done. The parking levels are typically below the podium slabs. They can be parking and or retail. As we're doing more and more of these, they're used for a lot of retail spaces. A lot of times these podium buildings are almost like little cities, so you park, let's say, at the lowest level, and then at the level at grade or right below the units, you'll have a Starbucks Starbucks, maybe a 7-Eleven, convenience type stuff, so that in theory, if you park your car on a Friday night, you maybe don't have to leave your apartment again until Monday morning. So a lot of times these are getting dressed up more and more to be commercial and parking, not just parking as it was kind of back in the day. The other thing is the Podium slab provides a fire separation between the parking, retail, and the living areas, and this needs to be accounted for, in the design of the PT slabs, and I'll get to that specifically what that means a little later on in the project. As I mentioned before, the interesting thing about Podium slabs is not so much the numerics, because again, a two-way slab is a two-way slab regardless of thickness, but it's interacting with the plumber, the electrician, the architecture, the landscaper, stuff like that. There's a lot of different pieces and parts that goes into these things. If you compare one of these decks to, let's say, an office building, a hotel, or even, let's say, a straight parking garage,